Okay, let's try again. We have only now 40 minutes, and in the agenda for this initial seminar, I was counting for something like 45 minutes and 5 minutes for questions. So I was explaining that first I will introduce the motivation of doing this type of hot topic identification, how we did it in collaboration with the students of my research group. And then I will go one by one in 10 topics. I won't be able to spend more than 2 or 3 minutes in each of one. And there is another part of the talk where I wanted to share some ongoing trends in scientific events, so conferences, workshops. There are some updates in the community on how to run these events and some new practices I wanted to share with you. Well, following the state of the art is part of any researcher. So what is going on, why, doing the literature review, if you want to take also decisions where to invest in terms of your time, in terms of resources. It's important to know what is going on, why. Okay, so the objective I already introduced, going through 10 selected ones, and then commenting about the scientific events. Some disclaimer, well, what is a hot topic is very subjective. I try to follow some systematic methodology, but this is certainly not complete, or maybe you ask 100 colleagues in the field of networking, they will come up with 10 different sets of topics. Maybe we agree on 5 or 6. Could be an interesting exercise, actually. Maybe I can put a poll out in LinkedIn and ask, hey, what are in your opinion, the 10 hot topics? And then just the topic terminology itself, it's a challenge that we converge, because there are some terms that are used for the same topic, use different terms. Okay, and a hot topic does not necessarily to be a topic that is fundamental, that is critical, traditional, like a traditional problem in networking is routing. There are many algorithms, there are many techniques that are relevant. Security. Okay, what else? Host implementations, transport control, congestion control. This is a classical problem in networking. It's not hot anymore. Well, the hot comes because it's emergent, because it has potential to impact, to change the status quo, to bring new insights. That's what we understand with this term. But again, that's it. There may be a hot topic that goes nowhere, or that does not meet the expectations. If you look at these hype curves, it looks like it's going to change the world of the field, and then at the end it goes down, or maybe mergers, evolves into something else. Okay? The other disclaimer is about, again, this is a subjective view, opinion, and does not correspond to any of employers or funders of the research that my group carries. Okay, so let's look first at how we did it, and we in this term means my research group in 3. So the students helped me in figuring out how we could come up with these hot topics. So we tried something that could be based on data. So we selected from the list of the most important top networking conferences, a list that was put out by by Professor Alberto and some colleagues in our community. This spreadsheet, you can find all these events with some statistics regarding the impact, and that way it creates a sort of ranking of the conferences. And then we went through the call for papers of each conference that usually identifies, lists a set of topics. So we looked into all of them, we parsed them through some scripts that were developed by the PhD student of the group, Rosano, and were used by the other students as well. So we divided and tried to conquer the space of conferences. And finally, we put out the results in these data sets that you can also access. And then we identified topics that came up in the recent years, and also tried to discard those that went away. And that part was not fully automated, so that part was manually a little bit of thinking. And at the end, we came up with these 10 topics that I will comment about. So these are the 10 we selected. Intent, the concept of intent applied to networking. As you can see, there are more related terms in some cases. Okay, self-driving or closed-loop operations. These are sometimes used for that type of thing. Also, very nearby related is the concept of zero-touch management. Zero-touch means automation, means the operators do not manually do their work. They rely on software, on closed-loop automation. So it's difficult to separate, but there is if you go strictly, there is a separation. Common, they have automation. Common, they have relying on machine learning. But I opted to keep them as two separate topics because they also have separate standardization activities as well. Digital twins is the third one. We'll see how digital twins is being applied for networking, like in many other engineering areas. Metaverse, the famous Metaverse, is also an emerging hot topic for networking, also for other software engineering, social engineering, business. It's really cross multidisciplinary. Blockchain, the part of networking in blockchain is also arguably a hot topic. Machine learning, artificial intelligence, of course, in all the fields, could not be different for networking. High precision networking, so networking for industrial environments, evolving the protocols so that they meet the needs of industries, of controlling machines, robots, drones. Quantum, not just computing, but also quantum communications. Quantum internet is also a hot topic. I will have a seminar already scheduled on this specific one. 6G, we are rolling out 5G, experimenting with 5G, but 6G has already started the research towards 6G. So I will comment also about it. And finally, OpenRAN, or disaggregating RAN, or this network disaggregation, but that could be too broad, maybe. So I opted to just name OpenRAN and focus more on the radio access networks. Okay, so if there's an event that has the spirit of focusing on hot topics, that's Hotness. It's an ACM workshop in the 21st edition already, and it has precisely this spirit, touching, focusing on this type of topics that are not yet fully worked out. So if you read the call for papers, I highlighted here some of the aspects that they highlight, what they are welcoming. So they welcome works that have novel ideas, open questions, so there are position papers. Position papers mean that they don't need to be fully backed up with experimental evaluation or with theorems or with proofs, just well-written, elaborated ideas, not well-reasoned arguments, preliminary work, early stage work, okay? And to stimulate reflection and discussion in the community. That's the idea of this workshop. I really like seeing the proceedings. It's good to see where things are going on. This is an excellent source for that. Oh, my battery went out. Oh no, just leaving. Okay, so if you look at the 2022 edition, here you can find how, of course, the hotnets does not have a list of topics in the call for paper, but it has at the end sessions of the accepted papers where you can identify sort of some of the themes that were common. It's hard to organize the sessions in this type of event. Also noteworthy is that the authors are commonly a combination of academics and industrial folks. So we see the industry driving many of these techniques, of course, not just crazy professors or academics trying to sell out new ideas that make no sense. So here I highlighted a couple of them that appear in the selected topics. Okay, so I already mentioned about this hype cycle. I guess all of you have seen this at some point, the famous Gartner hype cycle. This is certainly one way of seeing, following hot topics, not just in networking, but in multiple disciplines in IT technology. And another one that I like, and I always try to push towards something that may be happening nearby, like at CPKD R&D Center. This is the technology radar or state-of-the-art radar, and we'll have, as I already mentioned, next week, the main person behind this initiative will explain how they designed this radar and what are the main technologies that have been explored, and also the timeline. There is an importance about time, the maturity, and how fast they are moving, right? Okay, so let's start by the first hot topic. So intent-based networking can be seen as an evolution of software-defined networking that try to layer the architecture by separating the data plane, the control plane, and the applications. It's like trying to follow a computer-sized layering model approach, like operating systems do, that they put abstractions. So it can be seen as an evolution where there is a control loop to take automated decisions, automation in the network, in reconfiguring devices based on policies and models for device services. So it's a strong model-based approach. Highlight is the concept of an intent. That's a high-level declaration, and it has a language itself. There is also an intersection these days happening with natural language processing, ChatGPT type of systems that recognize intents. There's also some intersection going on. And the user, the operator, the system administrator, the network administrator, declares what it expects from the network, like connectivity from point A to point B, with some properties in terms of bandwidth, throughput, survivability, and so forth. And the software that controls, that manages the network, needs to verify, needs to first install all the configuration, calculate all the configuration, deploy it, and then at runtime verify that the intent is being delivered. And in case that the intent is not being delivered, then take the remediation actions to reconfigure the network so that the intent is being met, or raise the issue and get the user know about the issue. Well, if you were to read more into this, you will find many papers, of course, some of them from our group. But you will likely want to start with a survey, right? A literature review. That was the main topic of our second class, how to do it. So most of the papers, the selected publications that you will find behind each of the topics is a survey. And in this case, I selected this one, so recent for 2022. I tried also whenever possible to take the most recent one, and it's very well written, as you would expect for a survey, and goes into all the developments around the intent-based networking domain. Another discussion point that I bring to each of the topics, whenever applicable, whenever relevant, is standardization. Standards are critical for networking, for interoperability. It's the basis of any distributed systems that the different implementations interwork. So I try to, whenever possible, an adequate point to ongoing standardization work. Here we can find two very recent RFCs from IETF. They were research from the Networking Management Research Group from IRTF. And here you can find a reference architecture and also an intent classification. So what are properties of intents, transfer, underlay, intent type, intent scope, and so forth. It's extremely. So let's move into the second one, zero touch management. I don't have the concept slide here. I don't know what happened, but it's about taking out the human in the loop, a little bit like a intent, but with a slightly different scope. Here the selected publication is another survey on network automation solutions, focused on mobile networks, on 5G and 6G, the vision on 6G. And here there is relevant standardization as well by the European Telecom Standards Institute, ETSI. It has a group, it's called CSM, Zero Touch Network and Service Management. It has a scope, a reference architecture, where you can see the APIs or the interfaces to make this type of networks that can span different domains, physical, virtual, as a service, cloud, and also administrative domains, how to interconnect, this is what is going on, to be able to define these interfaces, to create solutions based on this automation, management, and that. Okay, let's move to the next one, digital twins, network digital twins. Are being used in multiple fields in engineering to create a digital version of a physical object so that engineering practices can be accelerated, improved on this digital copy, so that at the end the physical object gets improved in some way. Well, now for networking, the digital object is the network. It's a network with some properties in terms of nodes, or technologies, or optical communications, or wireless, or packet. And here the idea is to create a mirror, something that is equivalent to the actual network. And then for that, you need to be able to read everything that you can learn, not just one time, but continuously, so that the digital version of the network is up to date. And then you use the digital object to create some hypotheses, to improve some planning. In this work, in collaboration with Professor Darby, for instance, and funded by PadTech, we are doing, for instance, the applying machine learning to this digital entity. We are doing localization of failures, soft failures, identification and localization, or quality of transmission estimation as well. Selected publication, it doesn't have survey in the title, but it's a survey type of work. Network digital twin, context, enabling technologies and opportunities, also very recently published. Very well-known folks in the networking community in standardization. Here you can see many of the applications that are being used: what if scenario, network planning, optimization, troubleshooting, what happened, where was the root cause of a failure in the network. These are types of applications that the digital twin solves, where traditional management techniques are not capable. We'll find the techniques, the machine learning models, or the enabling methods for this type of applications. Very interesting work. I know several colleagues working on this as well right now. Standardization, also at the Network Management Research Group, so the research track of IETF, we can find some works, not fully complete right now, so not in the form of an RFC, but of a draft. I selected this one that presents the concepts and the reference architecture of a network digital twin. Here you can see some of the authors of the survey are also authors, and some of them also, one of them at least, friend. Right. Okay, let's move to the Metaverse. Well, the Metaverse is very immature, very controversial, I would say. So there are different views, approaches being pursued. So there is little concrete, consolidated works. It's a combination of multiple technologies, emerging technologies. So it includes digital twins, XR, augmented reality, virtual reality, mixed reality. That includes, of course, machine learning, includes new models, economy models, blockchain, new currencies, cryptocurrencies, and of course 5G connectivity, very low latency type of connectivity, to have all the persons interacting in this digital way, this digital world, in a way that the experience, the quality of the experience is not. So, for networking, there are multiple technologies, high precision networking, federation, semantic technology, all of them are being seen as enablers to realize the most ambitious visions around the realization of a metaverse. And another way that, another term that I like is calling the Internet of Place, or place, the Internet of Ownership. This is nice because it would be an evolution of Internet of Data in the 1990s, Internet of People in the 2000s, Internet of Things in the last decade, and this could be seen as the next, the future of the Internet, the next Web 3.0. Selected publication, 2022 survey, in the well-known IEEE communication surveys and tutorials. Vehicle, journal, and here you can see a picture that tries to summarize the concept of the digital world. Standardization, there is little standardization for a metaverse, but there are certainly multiple activities to get together folks to realize APIs or the models or the consolidation of technologies. And so I selected some special interest groups of IEEE, of ACM, and also I point to a conference, the first conference, IEEE conference, that focuses on the metaverse, on computing networking applications, called Metacom 2023. Will happen in Japan, I think. Okay, blockchain networks is our next topic. I guess all of you have heard about the blockchain, about the bitcoins, right? And here, what I highlight as a hot topic is can be divided in two main subtracks. One is research in blockchain advances, core enablers around the networking aspects. So how you make the ledgers, the distributed ledgers, more efficient, more responsive, more fault tolerant. How do you construct the networks in a better way for blockchain type of applications? This is one way. The second way that I divide is how do you apply blockchain technologies to the networking itself? How do you replace traditional databases, centralized databases, with distributed blockchain type of? How do you create a marketplace for providers of communication, of computing? So how do you apply blockchain to networking? You can see it's a different way of looking into it. RMP has also a study group that recognizes the relevance of blockchain, the opportunities as well. And here, another survey for those who may be interested in the blockchain networking aspects. Here you can see how to divide it into multiple challenges around topology, payment, measurements. How do you measure the performance, the scalability? All of these are full of challenges. Now, artificial intelligence and machine learning, like any other field, networking has been hit by AI ML now for 5 to 10 years, 5+ years, increasingly adapted, understood, still being understood and applied. So you can call it network protocols. Traditional network protocols meet AI ML for optimized configurations, for optimized deployment, running operations of the protocols. you can find machine learning for networking, for network management. This we already saw or were present in intent-based networking. Same way, you must recognize networking developments to support distributed ML workloads. So you see machine learning as a distributed computing application that benefits from improved networks, from data centers that are more performant, more scalable, that make the data flow. Of course, I won't enter here the discussion on where stops machine learning, where artificial intelligence starts, but this is, of course, some of the ongoing tracks. Well, like for any other fields of applications, it tries to solve problems, complex problems in a feasible way. And there are multiple applications for prediction, for optimization type of problems of many types. There are main standardization activities because machine learning is about data. So if you don't have quality and volume data, you cannot do machine learning of impact. So all these networks have boxes, management systems, each of them produce their data. So if you don't start thinking about your networks as in a machine learning type of and compatible pipeline, then you are not able to produce solutions that exploit machine learning. So all the main startup development organizations and new architectures are thinking how to model, standardize APIs to have these machine learning solutions in place. Also our R&B, the National Research and Innovation Network of Brazil, has a technical committee looking into relevant aspects of machine learning. Actually, they call it data science and artificial intelligence. Here, another survey. Oh, that's great. Another survey with many of the fields where machine learning is being applied, the techniques. Let's move to high precision networking. This is making the current networks that are not sufficiently precise in terms of packet loss, in terms of jitter, in terms of what else? Throughput or capacity, available capacity. These are all needs that for any industrial application you really need. So if you are controlling through a network a robotic arm or a drone or a critical sensor that collects data from the energy plant, you cannot afford losing packets, having packets being delayed. So for all these type of industrial applications, deterministic performance and very low latency are critical. So TSN is the term that the IEEE standardization adopted, so time-sensitive networking. But we have also at IETF a working group that calls it's called DETNet. So both of them are types of high precision networking at different layers, Ethernet, IP, and different approaches and scope, but both with the same background objectives. And here it's a position paper, it's not a survey paper. I'm sure there are some surveys, but I thought this was more illustrative. It's also from a colleague of mine, Alex Clem, and it's a nice reading. Standardization, I already mentioned these two tracks. Let's move to quantum very quickly, because we have a seminar in a couple of weeks by Professor Abele from the Federal University of Para. Here the idea is to exploit the quantum mechanics, the properties of entanglement for doing links, communication links with very strong security properties. So that's the main argument. It's not a replacement of the traditional internet that can be and will be used in parallel, for instance, for the transmission, but this quantum network can solve very hard problems like those related to the distribution of cryptographic keys in a secure way. So you can use this network to distribute the keys, and then you can use the traditional network internet for the actual data transmission. But we'll learn more about it. There is another very nice communications, IEEE communications survey on the quantum internet. Okay, 6G or beyond 5G or 5G and beyond. Why? Because it's still a vision. There is no reference architecture. There is no nothing defined yet. There is no specification. There is no requirement. So this is right now happening, as you can see in this timeline at research, 6G research, standardization, just creating the vision. What should we expect and how to get there, how to evolve the technologies, the enabling technologies to meet what we think that 6G should be delivered, to address use cases that are very hard, even with the latest 5G release. Okay, for different types of use cases. KPIs that are more complicated to achieve, so 10 times more capacity, 110 times more density, lower latency. These are some example numbers that you can find out in the initial literature around what 6G networks or how they could look like for a couple of challenging use cases for industry, for 3D presence, and so forth. Okay, so there are more. There's another reading over there on a survey, and a couple of initiatives. The first one was the 6G flagship in Finland. In Europe, there is a strong research program that is called 6G SNS. And in Brazil, we have Brazil 6G by R&D, Inatel, and other institutions looking into use cases, enabling technologies. Also, all the material is the website. And here at our faculty, we are leading an engineering research center co-funded by FAPESP and Ericsson. It's called Smartness 2030, Smart Networks and Services. And we are starting officially in April. And for 10 years, we will be developing enabling technologies for 6G for the 2030 landscape. RAN, it's about disaggregating radio access networks, so it's about creating modules, it's about breaking boxes that were traditionally fully integrated in hardware and in software. The box itself, horizontally, having its modules, its interfaces, and also the network, likewise vertically and horizontally, the network, so what goes into the antenna, into the radio base station, into the different parts of the network. All this disaggregated where you can pick and choose different split options, different vendors. There are a couple of alliances and organizations to realize this vision, ORAN, and also ONF, SDRAN, and we'll have a talk from an alumni of our faculty talking about the experience of running an SD-RAN in trial in Berlin. And another Brazilian initiative, it's called OpenRAN Brazil, also with R&B and CPTD, a project to create, develop this type of architectures and create the knowledge, the competence to create solutions of this type of disaggregated networks. Here is a nice survey around ORAN for those who would like to learn more. There could be more topics. I selected these 10 ones. We can agree to disagree. I agree to disagree. I would like to know if anyone today or in the future has another suggestion for a topic or would challenge to remove one of the ones that I mentioned. ChatGPT, OpenAI, what will come, these are all other candidates, actual slicing. Also, if we go just into optical, or just into wireless, I'm sure we could create another 10 lists at each focused about developments, reconfigurable interfaces, surfaces. High level. And my suggestion would be to stop the talk over here. I know many of you have at 2 p.m. other classes. Apologies. I will deliver the second part of trends in an upcoming opportunity. Okay? So,